Hello, Integrated Math 1. Welcome to lesson 2.1.2c. So we're on our third day of this, making sense of different representations of a linear function. We've been doing pretty good so far, but we're about to kick it up to the next level today. So we've already determined whether scenario, equation table, graph represents a linear relationship. We're always looking for that constant difference, that average rate of change, all that good stuff. We've been calculating the average rate of change, which we know is the slope of our function. We've been writing functions, right, given a table of values and even just scenarios. And we've also been digging into interpreting these expressions that represent different quantities in terms of context or graph. We're talking money, t-shirts, what is it we're talking about here? And we're also going to start today comparing different equation representations of linear functions. That's where we're going to start digging in today. We're also going to start finally hitting our key terms: polynomial, degree, leading coefficient, zero of a function. We're going to start touching those today. So you know how to determine whether a relationship represents a linear function. You know how to write an equation for that function. We've been doing super great with that. So let's dig a little deeper on using the structure of that equation, identifying the characteristics of our function. So we're on page M2-30 today. And we're going to look at what happens when we start changing the graph of our linear function. So we already talked in the past about Marilyn, how she was selling her t-shirts for $15 t-shirt. She wanted to make at least $100, right? All of that good stuff. But here's the deal. For the next festival, Marilyn's mom suggests that she still sells each t-shirt for $15. We're still doing that. But she should give away 3 t-shirts in a raffle. So this new relationship, G of T, is shown on the graph. So you can see, here's our original relationship, here's our original graph, E of T. This is what we had last time, right? But now that she's given away 3 t-shirts for free in that raffle, look at what's happened to our graph. It's shifted over 1, 2, 3 units. Because again, it's 3 t-shirts, and we said t-shirts was our X, and money was our Y. So now we've shifted over 3 t-shirts, and she's giving away 3 t-shirts. Fair enough. So here is G of T. This is what we're going to start examining today. This is what we're going to start playing with today. So compare the 2 graphs. Would you notice, starting with A, how do the graphs show the selling price per t-shirt remains the same? Remember her mom said don't change the selling price? How do the graphs show that the selling price hasn't changed? Hit pause, jot down what you're thinking, and hit play when you're ready to check it. So she's still selling them for $15 per t-shirt. And if you recall from last time, that was our slope, right? That was our average rate of change. So sure enough, both graphs have the same slope. Both graphs have the same rate of change. So the price per t-shirt has not changed. Our slopes have stayed the same. Our average rate of change has stayed the same. But now, I'd like you to determine and interpret the meaning of G of 0 in terms of the graph and the scenario. And I'd like you to label the point on the graph. So can you find G of 0 on your graph and tell me what it means? Go ahead and hit pause, work this out, hit play when you're ready to talk about it. So first of all, I found it on the graph. I was like, okay, G of 0, that means that's when x equals 0, right? So this is when x equals 0, so it looks like it's down here. Ooh. So it looks like that point is at 0, and I didn't quite make it to 50, so we'll say that's what, 0, negative 45? Oh dear, oh dear. So G of 0 is represented by the point 0, negative 45 on the graph. And what does this mean for us in terms of the scenario? Oh dear. Last time we said if she sells 0 t-shirts, she makes $0. But now she's giving away 3 t-shirts, guys. This means that if she sells 0 t-shirts, she loses $45. So she sells no t-shirts. No t-shirts are sold. Marilyn's potential earnings is negative $45. She'll lose money on the deal. Yikes. Okay. What does g of t equals 0 mean? This is a little different. So what does g of t equals 0 mean? Again, in terms of the graph, in terms of the scenario, where's the point on the graph? Just like last time, only we changed it a little bit. Go ahead and hit pause, work this out, jot down your thoughts, hit play, keep going. Last time we said g of 0 meant that's when x equals 0. But now I'm saying g of t equals 0. So I'm actually saying, dude, when does y equal 0? Well, on g, y equals 0 right there. That's where y is 0. Boom, there it is. Oh, so that's actually not a y-intercept anymore. That's now an x-intercept, isn't it? So it looks like the point is at 3, 0. So g of 0, g of t equals 0 is represented by the point 3, 0 on the graph. So it's where it intersects my x-axis, not my y-axis. In terms of the situation, that means if she sells 3 t-shirts, she made $0. So once Marilyn gives away her 3 t-shirts, she's earned no money. Yeah. So even if she sells 3 shirts, she hasn't earned anything yet. That's very sad. So Michelle and Myra each wrote an equation to describe the effect of giving away 3 t-shirts. Check this out. So Marilyn is giving away 3 t-shirts. So she has 3 fewer t-shirts to sell. So she said that means g of t equals 15 times t minus 3. Because now she whatever number of t-shirts she sells, she's got to take out 3 of them because she's giving them away. Myra said, well, but the cost of giving away those 3 t-shirts is $45. She's like, that's my y-intercept. So she said 15t minus 45 is the function. They're both right. Why? Can you show me why they're both correct? Go ahead and hit pause, do a little bit of work here, and then hit play when you're ready to check your work. So I did a little bit of work here. I took this guy and I was like, well, that one, Michelle's has parentheses and Myra's doesn't. So I took Michelle's equation and I was like, well, then I'll distribute, right? I'll do a little distributive property here and we'll get rid of those parentheses. So I did 15 times t and then 15 times 3 with the minus sign in the middle. So I actually do get 15t minus 45. So they are the same function, aren't they? I want to point something out here. It's not in the book, but I want to point something out. These are the same equations. These are the exact same equation. They both use the slope. Did you catch that? They both use that slope, $15 per t-shirt. They both use the slope. But notice, Myra used the y-intercept, where it hits the y-axis, and Michelle used the x-intercept, where it hits your x-axis. Oh. So they both use the same slope, but they use different intercepts. This way of writing it is what we call factored form. So when you're writing the equation in factored form, you're still using the slope, but now you're using the x-intercept to write your equation, and it does mean you need some parentheses there. When you do it the traditional way that Myra has here, we call that general form. That's a general form of a function. And that's going to be important for your homework. Because on your homework, I believe it's going to ask you to write it both ways. Write it in the general form, the way you've always done it. You know what, you love it, slope, y-intercept, yay. But also write it in factored form. What's your x? Use your slope and your x-intercept with those parentheses. So we can't write it 2 different ways. They're the same equation, right? You get the same stuff. It's the same equation. It's just 2 different forms of the same equation. So with this in mind, let's go back. We had this question before and it's coming back to us today. How many t-shirts will Marilyn need to sell to earn $100? Make sure we're using the G of t this time, not the E of t. All right, we're on the G of t now. You can use the graph, you can use the equation. Either way is fine with me. Figure out how many t-shirts she now has to sell to earn that $100. Go ahead and hit pause to work this out. Hit play when you're ready to check your work. So I'm taking it back. I am bringing up the equation. I like the equation. So I'm gonna do the equation. Remember last time where we said that $100 that's gonna get substituted in for your G of t. This is now your Y value. So I did that. I was like, okay, so $100 equals 15t minus 45. Yay. And now, people, it's time to do the work. So I'm going to add 45 to both sides. So I have 145 equals 15t. I'm going to divide both sides by 15. That's why my calculator, 145 divided by 15. And I find out that t is about, and I'm going to round it to 9.67. I'm going to round a little bit there. If you wanted to see, and hang on, I'm going to erase this because I'm going to show you the pretty typed out version. Isn't it pretty? It does mean I need to round. It does mean I need to round because remember, we can't sell 0.67 of a t-shirt. If I sell 9 t-shirts, that won't be enough to make the $100. So I'm going to round up to 10 t-shirts. So Marilyn needs 10 to sell 10 t-shirts to earn her $100. Of course, I did mention that you could also use the graph. By the way, the only reason she has to earn more shirts, remember, she's giving away 3 shirts. Earlier we said she only needed to sell 7 shirts, but now that she's giving away 3, she's going to need 10 to earn her $100. The graph, we said you could do this with a graph, right? So here's my 100, so I'm going to draw a line right through there, and I'm like, it hits right here. And okay, so to earn $100, and I'm just going to match it with my x-axis. Again, looks like it needs to hit about 9.67 again. Hey, there it is. So again, you could use the equation, you could use the graph. The equation's funky because we did have to round. The graph's funky because it's hard to tell exactly where that is. The only reason I knew that number is because I used the equation to get there. But you get the idea. Lovely. So the linear functions that Michelle and Myra wrote are equivalent. They're just written in different forms. So this one we said was written in factored form, and then the one that Michelle wrote was in factored form, and the one that Myra wrote was in general form. But they're both linear functions. Just Michelle's form used our x-intercept, Myra's form used our y-intercept. But they're the same thing. They give us the same stuff. A linear function can also be referred to as a polynomial function. A polynomial is just a mathematical expression involving the sum of powers in one or more variables multiplied by coefficients. I'll show you what I mean in a minute if that feels a bit much. The degree of a polynomial is the greatest variable exponent in the expression. Again, I'll show you what I mean in a minute. And the leading coefficient of a polynomial is the numeric coefficient of the term with the greatest power. So let me show you. I think this will work better if I show you. So here are some polynomial functions. This is a constant. We talked about this a few days ago, right? We talked about a constant function. It didn't have a slope at all. So we said it had a degree of 0 because there's no variables here. There are no variables in this. It's a constant function. So we say it has a degree of 0. Here's my linear function. You recognize this, slope, y-intercept. Isn't it great? Now, we don't usually put an exponent on the x, but if we wanted to, I could put an exponent of 1. And so I would say it has a degree of 1. I would also say the leading coefficient is 2. For a quadratic, the key was that x squared. Well, because it has an x squared, that means it has a degree of 2. And my leading coefficient will be 3. And this is actually what we call a cubic. We won't deal with cubics in this class. You will deal with cubics in a future math class, and not this one. So you're going to have 4x cubed minus 2. It's also a polynomial, but now since I have an exponent of 3, it has a degree of 3. And since there's a 4 in front of that x cubed, my leading coefficient is 4. But these are all polynomials. These are all examples of polynomials. That exponent tells me what my degree is, and the number out in front of that x tells me what my leading coefficient is. And that's all there's to it. When you graph a polynomial, the degree actually tells you the maximum number of times the graph can cross the x-axis. Like I said, you'll dig into that more in future math classes. For us, since we're dealing with linear functions, it's only going to cross our x-axis once, and it has a degree of 1. So the structure of each linear function tells you important information about the graph, right? Like for example, our linear guys, f of x equals ax plus b, where a and b are real numbers, a is not 0. In this form, we would say that a value is our leading coefficient, right? It describes how steep our line is, the direction it's going, up, down, increasing, decreasing. And of course, we know that the b value is the y-intercept. We also know this form is y equals mx plus b. We've known that it's slope-intercept form, but these are the same, again, and being the slope, how steep, increasing or decreasing. B, again, represents our y-intercept. These have the same structure, and like I said before, this is called the general form of our equation. So the general form shows that a linear equation is a polynomial of degree 1. We're not going to stress about this too much. You'll learn more of this as you progress through your math classes. So I would like you to consider the general form of this lovely linear function g of t. Can you find a on the graph? Hit pause, find it, right, make your little notes there, hit play when you're ready to check your work. You guys know, so general form, if I come up here, we're all in general form, looks like this. Ooh, sorry. We know that the a value is just our slope, that's it, the a value is our slope, yay, good job us. So if I wanted to find the slope, we just do a little rise over run, so this would be my a value, my rise over my run, hooray. So a, and in this case, I'll say 1. Where's b on the graph? Go ahead, write it down, hit play when you're ready to check your work. So we said the b value is, of course, our y-intercept, and that's right here. Boom, boom. There's our y-intercept. Good job. Now let's talk about that factored form. We talked about the factored form before. Let's talk about it again. So we know that general form is f of x equals ax plus b, but check out factored form. It's f of x equals a times the quantity x minus c. All right, and that's changed things a little bit, right? We still have a, it's still there, but that c has a few names. We earlier called that an x-intercept, but it has another name. The other thing we call that is the zero of the function. So when a polynomial is in factored form, the value of x that makes this factor, x minus c, whatever makes that equal to 0, that's going to be your x-intercept. So we call it the zero of a function, because if I plug that in there, that's what would make that equal 0, right? A zero of a function is a real number that makes your function equal to 0, f of x equals 0. So you can set x minus c equal to 0 and determine the point where the graph crosses the x-axis. So we're now saying this is our x-intercept, also known as the zero of a function. Make it right here. Zero of a function. So like I said, we touched on this a bit with Michelle's equation earlier. So now that we're back looking at our graph, again, find the a value of your graph, find the c value of your graph now. Go ahead and hit pause, jot down your thoughts on this for A and B, hit play when you're ready to check your work. So again, A is the slope of the graph. We know that, rise over run, there it is, hooray. But now let's talk about C. We said that the C value is the x-intercept of the graph, or the zero of our function. So that means it's going to be right there. So there's my C value. My C value is 3, isn't it? Ooh, so what's the zero of the function? It's 3. Yeah, the zero of g of t is 3. Remember that the zero of a function just means it's the x-intercept. Hey! Yay. Yeah, so, and it's that because it's the value of t that makes this equal to 0, right? If I were to plug a 3 in there, 3 minus 3 would be 0, 15 minus times 0 is 0, it would make my function become 0. All right, we got another situation here. So Marilyn is still giving away 3 t-shirts. Good job, Marilyn, because her mom told her to. But at the next festival that Marilyn is attending, it charges a $35 fee to rent a booth. So she's still selling her mom's t-shirts for $15 each. She's still giving away 3 in a raffle. But now we have a new situation, right? Because now we're charging $35 just to rent a booth. So the graph shows this new relationship. We're calling it f of t, capital F of t. How does the graph show that the selling price per t-shirt remains the same? Hit pause, jot it down, hit play when you're ready to check your work. So you may have noticed the slope stayed the same. Both graphs still have the same slope or average rate of change, still $15 per t-shirt. But how did the new booth fee of $35 change the graph? What did that do to our graph? Hit pause, jot down what it did to our graph, and then hit play when you're ready to check your work. So the fact that they're now charging $35, earnings are on the y-axis. Check it out, it pushed our graph down 35, right? It's now gonna cost her another $35. So that means our y-intercept, instead of being negative 45, it pushed it all the way down to negative 80 because we're another $35 fee, that's another $35 loss from our earnings. So our y-intercept is now shifted down to negative 80. Whew. So how many t-shirts will Marilyn need to sell before she'll have any money to return to her mom? Hit pause, take a look at the graph, write it down, hit play to keep going. So check it out. My x-intercept has now changed as well. In addition to my y-intercept, which is now down here, my x-intercept has now changed because I want to know how many t-shirts, well, shoot. If she sells 5 t-shirts, that's not enough. It looks like she's going to need to sell at least 6 t-shirts before she's going to have any money to bring to mom. Look, negative money, negative money, negative money. Whew, it's not until we hit 6 t-shirts that she's making anything. So looking at the graph, the y values, which represent potential earnings, are positive, but not until you've sold 6 t-shirts or more. Yeah, she needs to sell at least 6 t-shirts. So how many t-shirts is Marilyn going to need to sell to earn $100? Go ahead and use the graph. Go ahead and use the graph. See if you can figure this out from the graph. Hit pause to work this out. Hit play when you're ready to check your work. So because I don't have an equation this time, I've been relying pretty heavily on those equations. I'm gonna use the graph. So $100, I'm gonna draw my line across. Okay, that is where it hits my graph. Awesome, awesome. So this is where it hits my graph. So I'm gonna boom. Oh man, and that's what, 12? That looks like a 12 right there. Yeah. So f of t equals 100 when t equals 12. So Marilyn's since she's giving away 3 t-shirts, she's paying $35 to rent the booth. She's gonna need to sell 12 t-shirts, 9 on top of the 3 she's giving away there. She's gonna need to sell 12 t-shirts in order to make $100. Can you write the function f of t in terms of g of t? This is tricky, but hit pause. See what you can do with it, and then hit play when you're ready to keep the discussion going. I want f of t, but I don't have an equation for f of t. But I do have an equation for g of t, right? And we said that we're taking off another $35. So I can write f of t as being g of t minus 35, right? Because we gotta pay another $35. We're losing another $35. Can you then take that you just wrote, and can you rewrite it in general form? Can you substitute in your equation for g of t and see if you can clean that up a bit? and find your A values, your B values, all that good stuff. Hit pause and work it out. Hit play when you're ready to check it. Now I'm going to show you two things. First of all, we know what G of T is. There's no question mark there. We know what G of T is. Get rid of that question mark. We know what G of T is. We had it earlier, right? We said earlier that G of T was 15T minus 45, right? So I'm just going to plug that in. So instead of f of t equals G of T minus 35, I'm going to say f of t equals 15T minus 45. And I still have a minus 35. I can, of course, combine my like terms because I'm a good girl like that. A negative 45 and a negative 35 gives me negative 80. Of course, you totally could have used the graph as well because you know that the slope is 15 and you already knew that the y-intercept is negative 80, so you could use that to write your equation too. Here's a tricky bit. I would like you to take this lovely f of t that you just found. And I would like you to rewrite it in factored form. You may have to use a fraction to represent your C value. Fractions are okay, fractions are our friends, we're cool with fractions. And then describe what it is you found with your A values and your C values in factored form. Go ahead and hit pause, see if you can work this out, and then hit play when you're ready to check it. So for factored form, I want it to look like this, right? I want my slope to be split off of my variable. So you know what I'm going to do, as weird as it is? I'm going to divide everybody by my slope. So I'm going to put so that means my slope, I'm going to factor it out. I'm going to take it out here, and then I have minus 80 over 15. Ooh. That's how you turn it into factored form. Now, the one thing I am going to say is that we can simplify this. You can simplify 80 over 15 because I know that both of those are divisible by 5. So I'm going to grab my calculator real quick. 80 divided by 5 gives me 16. And of course, 15 divided by 5 is 3. So I'm just going to simplify it a little bit and look at that. Now, I am in factored form. What? So all I had to do is divide out my slope and put it out in front. So if you have it in general form, but you want it in factored form, you can just divide the slope right out of it, put it out front. I did need to simplify my fraction a little bit. I'm going to erase these, and you'll see my pretty, there it is, my pretty typed version of it. My A value, of course, is my slope. It's 15. And now I have my x-intercept. I know it should hit my x-axis at 16 thirds. As always, guys, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, please feel free to email me or come see me during lunch, during office hours. You know I'm around. And I'll see you guys soon. Bye.